Chapter 3, Lesson 2 is over finding slope using a graph or a table. This is just an extension from yesterday's lesson. Part of it will be exactly the same as what you did yesterday because yesterday we found the constant rate of change. Well, constant rate of change and slope are the same exact thing. There is no difference between the two. Constant rate of change is just another word for slope. They mean the same exact thing and they are used in the same exact way. Yesterday, we talked about the constant rate of change being the change in y over the change in x. Well, today we're moving on to slope, which is just rise over run. So let me show you how that is the same thing. If you have a coordinate plane, it looks like this. Your up and down axis is your y-axis, and your side-to-side axis is your x-axis. So if you're talking about rising, rising goes up and down, which is your y. So your change in y is the same thing as your rise. And then your change in x, well, x goes side to side. And that's what they're talking about here is run, or your horizontal change. So side to side, change in x is the same thing as run. So anytime you hear constant rate of change, which is your change in y over your change in x, it is the same exact thing as your slope, which is your rise over your run. Because on a coordinate plane, your rise up and down, change in y, is a rise. And your horizontal change, side to side, x, is your change in x. So change in y over change in x is the same thing as rise over run. So for part of the lesson today, we will be doing exactly what you did yesterday. For the other part of the lesson, we will just be applying what you did yesterday in different forms. So it'll be easier to find that slope when it's given to you on a graph here already, where you don't have to go in and do as much math doing your, this is adding. So let's look at a couple different examples. First of all, it is important for you to know that there are 4 different types of slope. There is a positive slope, which means it is going uphill. There is a negative slope, which means it is going downhill. There is no slope, which means it is a flat surface. And then there is an undefined slope, which goes straight up and down. We watched a video earlier about the little slope man, or a little man walking up and down the hills. It kind of showed us some of that. And then I also showed you slope man. He's my favorite. And it's just a clown face. Look. So when you go uphill, it's positive. When you go downhill, it's negative. That's usually everyone's easiest to tell. Up is going down. Up is positive. Going down is negative. But then you have straight up and down is your undefined man. So his nose that goes straight up and down is undefined. And then his straight across face that has a slope of 0 or no slope. So here's our slope man's face to kind of help us remember the difference between those two. So anytime you have a graph going uphill, your answer should be positive. Anytime you have a graph going downhill, your answers should be negative. Okay, so a couple different examples. It says determine the slope of this water slide. Okay, well I see that it goes up and down. It's 18 feet tall and it's 40 feet across, horizontal and change. So to find the slope, I do my rise over run, and I need to see you write that out every single time. Rise over run equals, the rise of this is 18. The run, which is horizontal, is 40. So 18 over 40 must be simplified. Always, always, always leave it as a fraction. Okay? It's your change in y over your change in x. It's your rise over your run. It's set up as a fraction. Leave it as a fraction, but make sure that it's in simplest form. Okay? So 18 over 40 can both be divided by 2. So 18 over 40 would become 9 over 20. And that is my slope, or my constant rate of change. The next one, a hiking trail rises 6 feet for every horizontal change of 100 feet. What is the slope of the hiking trail? So once again, you must write out rise over run. That's how you show your work. It tells me that it has a rise of 6 feet. So it's going up 6 feet. And a run, a horizontal change, which is my run, of 100 feet. So 6 over 100. Put that in your calculator. Make sure that you get it simplified down. 6 over 100. This calculator is dead. 6 over 100. Well, I know both of those can be divided by 2. So that's 3 over 50. Okay, simplest form. All right, here translating rise over run, up is positive, down is negative, right is positive, and left is negative. So we kind of already talked about Mr. Slopeman and his face to help us determine positive and negative, but let's really look at that again on the coordinate plane. If I have my y-axis, if I'm going up, it's positive. If I'm going down, it's negative. Those are usually pretty easy for people to tell the difference for. On the x-axis is where some people start to get confused. Well, remember, this point right here is 0. So as we go forward this way, we're going positive. If we go back this way, it's negative. And that helps us here. Looking at this graph, before I even determine what my slope is, if I had my little guy and he was walking along, he would be, when he comes to this, he would be traveling uphill. Start on your left and go to right, just like you read left to right. Your little guy, as he's walking, he's going uphill. So this is going to be a positive slope. That is a visual check that you can do before you start doing anything. You should know that your answer is going to be a positive answer because it has a positive slope. So here it says the graph shows the cost of muffins at a bake sale. Determine the constant rate of change, which is just another word for slope. And it says, then determine the slope and compare the constant rate of change. Well, once you find the constant rate of change and once you find the slope, you're going to determine that they're the same thing. Okay? So, the easiest way to tell slope on a graph that is already given to you is find a point that crosses perfectly inside of a corner. So one like this, right here at 2, 4, crosses perfectly. And then find another point that crosses perfectly. So they use the point right here, 3, 6. Okay? To find my slope, I need to do my rise over my run. Well, if I started at one point, how do I get from this point to this point? I'm going to go up 2 and over 1. I went up 2, so it's a positive 2, and I went forward 1, so it's a positive 1. So when I go to do that, my rise over my run, I have to show my work here, and then I put rise over run is I've risen 2 and I've ran 1, so my slope is 2. Now, a lot of people ask, well, what if we did it the other way? What if I said, I started here and I went down 2 and back 1? Well, that would be negative 2 over negative 1. And my rise would be down 2, but my run would be a negative 1. So a negative over negative still gives you a positive answer. So you can do that both ways. Another thing is, what if we chose different points? What if I said that it crossed perfectly here at 0, 0, and it crossed perfectly here at 3, 6? I didn't pick 2 points that were right next to each other. That's fine. Because when I do my rise, I notice that I'm going up 6 and I'm going forward 3. So my rise over my run, I have to write it out every time. Rise over run is equal to 6 over 3, which simplifies down to the same number because it is constant. It is the same. So any point that you choose will work out to give you the same answer. So my slope was 2/1, which means that's $2 per muffin. And then they've gone through and showed you that the constant rate of change is the same. All I need you to do is find it, and you can tell me that slope and constant rate are the same. Okay? So here, when we go to do our our slope, we do it the same way we did constant rate of change yesterday. How do I get from 1 to 3? Plus 2. How do I get from 3 to 5? Plus 2. How do I get from 5 to 7? Plus 2. How do I get from 12 to 9? Well, I'm going down. And 12 to 9 is a minus 3. 9 to 6, minus 3. 6 to 3, minus 3. So my slope, again, is -3/2, which comes down here. They've also done your change in y over your change in x as a subtraction problem. That's fine, too. It's something that we're going to get into here in just a second. On your mathematics chart that you're given, you have a formula for slope. And it sets up something exactly like this. But if you notice, your change in y over your change in x is the same thing as your rise over your run, which is going to be the same thing as the next formula that we look at. But let's look at a couple more example problems before we move on. Here, determine the slope of each line. Letter B. I can tell that if I had my little guy walking across this line, he's going to be going uphill. So I know my answer should be positive. That's just a mental check that I'm going to make with myself to make sure I haven't made a mistake. So as I go from this point to this point, I can go up 3, up 1, 2, 3, and forward 1, 2, 3, 4. You must label that on your graph. It's super easy. You're just counting blocks, but you have to show me where you got that. And then you're going to come over here and you're going to tell me your rise over your run. Well, I have risen 3 and I have ran 4. So the slope of that graph is just 3/4. That's in its simplest form. I don't want to change it into a decimal. I just leave it as 3/4. Okay? Here, how do I get from 0 to 4? Plus 4. How do I get from 4 to 8? Plus 4. How do I get from 8 to 12? Plus 4. Just because this table doesn't go up and down doesn't mean that you do anything different. Then I'm using my y's. How do I get from -2 to -1? Well, that's a plus 1. How do I get from -1 to 0? That's a plus 1. And how do I get from 0 to 1? That's a plus 1. So I have a constant rate of change. And once again, I have to do my change in y over my change in x. So I'm going to say change in y over change in x would equal my change in y would be a plus 1. My change in x would be a plus 4. So my slope there would be 1/4. Okay, or 1/4. All right. Slope is represented using the letter m. So for your answers today, I would like for you to say m is equal to 3/4. M is equal to 1/4. And you're about to see partly why that's true here. And then as you continue on in your lessons, it will make it a lot easier if you already start associating slope with the letter m. Okay? So slope formula, it's one of the very first formulas that is on your mathematics chart. The slope m of a line passing through points x1, y1, and x2, y2 is the ratio of the difference in the corresponding y coordinates and the difference in the corresponding x coordinates. So what does that sound like? The ratio, which is a fraction, 1 over the other, of the difference of y, well, the difference of y is your change in y, over your difference of x, which is your change in x. So this is just using a whole nother set of vocabulary to say the same exact thing. Okay? So the symbols that we use is y2 minus y1 over x2 minus x1. So once again, let's talk about how this is all finding the same thing. your change in y over your change in x. Well, we said y goes up and down, so that's your rise, and your x goes side to side, so that's your run. So we said those two were the same thing. Well, now we're going to say the change in y would be y minus y, so y2 minus y1, over your change in x, which would be x minus x. And that formula is listed there on your formula chart for you. Something that is very important right here is it does not matter which point you define as your first point or your second point, as long as you keep that point together. So, the coordinates of both points must be used in the same order. So let's look at an example real quick, and I'll show you what will be required from me. Here it says determine the slope of the line that passes through 1, 2, and s negative 4, 3. I understand that you could come over here and you could do your rise over your run. I've noticed this is a negative slope. I know my answer should be negative. I've gone down 1 and I've gone over 1, 2, 3, 4, 5. So my slope should be negative 1 over 5. That is exactly what we just got done doing in the examples before. But sometimes they will not show you this on a graph, and they just want you to find the slope between these 2 points, and you have to use your slope formula. So that's what we're going to do an example of right now. First thing is you must write down the formula. So you're going to say y2 minus y1 over x2 minus x1. You do not have to have that memorized. You will use it so much that you will memorize it, don't get me wrong, but it's on your mathematics chart. So when you look at slope, it says n equals y2 minus y1 over x2 minus x1. So you just must copy that down. Secondly, you must label your points. So I have the point 1, 2, and I have the point negative 4, 3. If you remember, it doesn't matter which one you call point 1 and which one you call point 2, as long as you keep the points together. So I'm just going to use the first one as point 1 and the second one listed as point 2. So for all of your assignments, I want you to do that the same way. So the first point given to you is point 1. The second point given to you is point 2. In every single list of ordered pairs, you have the point x, comma, y. Now, if we combine that together with this being the first point, that just means that this is x of the first point, and this is y of the first point. And this is x of the second point, and this is y of the second point. You must label above each point, x1, y1, x2, y2. That will be required. If you do not have this written down, you will get points taken off. If you do not have this labeled, you will get points taken off. It doesn't matter if you get the correct answer or not. And then I have to see where you've plugged it into the formula, which is why I want everybody to use the first point as the first point given and the second as the second, so when we go in to check, it makes it a lot easier. Then all you do is put them in the places that they belong. y2, well, y2 is 3, minus y1, y1 is 2. x2 is negative 4, minus x1 is 1. And you just type this exactly how it looks into your calculator. You say, hit control divide to set up that fraction, and put 3 minus 2 on the top, and negative 4 minus 1 on the bottom. And it tells you that it is 1/5. So for my answer, I want to make sure that I say n is equal to 1/5. Sorry, negative 1/5. And your calculator will do that right there for you. Okay? Because 3 minus 2 is 1, and negative 4 minus 1 is negative 5. So my m is equal to a negative 1/5. Okay. So you're going to get some examples that look like letters D and E down here, where they don't have a graph. And so you're just going to use that formula. So you must come in and write your equation, y2 minus y1 over x2 minus x1. And then you must come on here and say that this is x1, and this is y1, and this is x2, and this is y2. So for my point, 2, 2, and 5, 3, I say x1, y1, x2, y2. And then they just go in that place. y2 is 3 minus y1 is 2 over x2 is 5 minus x1 is 2. Type that into your calculator and you get 1/3. So m is equal to 1/3. Go ahead and, because I do want you to get in the habit of saying m is equal to that number. Okay? Now e. E is where it gets tricky because there's negative numbers involved. Just make sure you stick to your formula. I have j is -7, -4, and k is -3, -2. You must write down the equation, the formula. y2 minus y1 equals over x2 minus x1. Then I'm going to label my points. You must label your points. x1, y1, x2, y2. Keeping this point is point 1, my second point is point 2. Then I set up my problem, making sure that I keep my second point first and my first point second. That formula sets it up there for you, so you don't have to do that mental in your mind. y2 is a -2. Minus y1 is a -4. So that is a minus a negative, which becomes a plus. But if you type it in just like this into your calculator, it will solve all that out for you. x2 is -3. Minus an x1 is -7. So now I have plugged in my points with exactly how they go. If you notice, my -2 and my -3 are together, my -4 and my -7 are together. They set it up there for you when you plug it in with your formula. -2 minus a -4 would be like -2 plus 4, which becomes a +2. And then -3 minus a -7 is the same thing as -3 plus 7, which becomes a +4. So when I simplify that, my slope is a +1/2. But if you were to plug this straight into your calculator, it would automatically yield you that 1/2 where you do not have to simplify or worry with any of that. So let your calculator do that work for you. This is not a lesson over adding and subtracting integers. That was something you did in 6th and 7th grade. Now we're using that to apply it here. So use that calculator to ensure that your answers are correct. Okay? So, once again, constant rate of change, slope, change in y over change in x, y2 minus y1 over x2 minus x1. Those all mean the same things. Those are all talking about your slopes. Slopes can be positive, negative. If there's no slope, if it's going straight across, if it's a flat surface, it has a slope of 0. And if it's going straight up and down like you're falling off a cliff and there's nothing there for you, that's an undefined slope. Okay? This is a very, very, very important lesson because this will just continue on to be used in the rest of chapter 3 and then in all the lessons to come.